Apple first time offers the 2TB storage version, and its price is. But repair industry offers its own solution. This is a 2TB NAND from iPhone 17 Pro Max. We have already confirmed that its type is S5e. In this video, we'll attempt to install it into an iPhone 17 Pro, to create a unique 2TB iPhone 17 Pro. First, we confirm the serial number and storage capacity. Connect the device to a computer, and confirm the original NAND type is S5e, which is consistent with the 2TB NAND. Power off the device. Apply some isopropyl alcohol around the screen edges to open it quickly. Disconnect all flex cables. Remove the screen. Apply protective sticker to the front camera module. Use a Torx screwdriver to remove the VC shield plate. After quickly removing the remaining components, take out the motherboard. Use tweezers to remove the heat dissipation foam. Protect the motherboard with high-temperature tape, especially the earpiece and Wi-Fi flex cables, which is prone to pseudo-soldering issue during heating. Secure it in the motherboard jig. Use a hot air gun to heat the area around the NAND to soften the adhesive. Then carefully scrape it away using a spudger. Continue heating. Until the NAND can be lifted smoothly. First, clean the pads, apply flux and mid-temperature solder paste. Use the soldering iron to neutralize the original high-temperature solder paste. Dip a cleaning sponge into the PCB cleaner to clean the pads. Remove the remaining adhesive residue using a spudger, to ensure that the pads are flat enough and won't affect the non-soldering. Next, apply some solder flux again. Clean the pads with solder wick. After cleaning, then let's check out the NANDs. As shown here, the 2TB NAND is noticeably larger and thicker than the 256GB one. Can this Big Mac be installed on the motherboard smoothly? First up, we try to place it. However, the shield in the upper left corner blocks it due to its larger size, and the 2 rows of the resistors will affect the new NAND installation. Use a bitmap to check the resistors. We found that the resistors in the lower row are ground resistors, which can be safely removed to make room for the new NAND. But the components in the upper row cannot be handled casually, and must remain in place. There is some redundant space on the upper left corner. It might be enough to fit the new NAND after careful grinding. But extreme caution is required to avoid damaging the EEPROM when grinding the shield. Once it's damaged, it cannot be replaced. Starting from the easy-to-handle resistors, apply some flux and remove the ground resistors in the lower row using solder wick. Carefully grind the shield with a grinding pen. Control the grinding force and try repeatedly. Pinch with tweezers and simply heat with a hot air gun until the small piece of shield can be removed. Place the NAND again. We thought that everything was finally ready to go, so we reballed once and planned to solder the NAND directly. But after flipping the NAND over and comparing the solder joints, we realized that the components in the upper row would interfere with the non-soldering. To solve this, we reballed the NAND again to increase the solder ball height, preventing component interference and ensuring solid soldering. Hold the reballing stencil firmly in place with tweezers and heat it evenly using a hot air gun. Remove the stencil and continue heating, until the solder balls form uniform and rounded spheres. Next, solder the NAND. Apply flux to the pads. Blast with a hot air gun. And gently align the NAND into position. Use a hot air gun to solder the NAND. Use tweezers to nudge the NAND into its final position carefully. Next, connect the power cable to the motherboard. Use tweezers to power on. Let's check the boot current. The current value looks normal, at 75 milliamperes. Reapply new heat dissipation foam. Now, we quickly reinstall the motherboard for a flashing test. Connect to computer and install the latest iOS 26 quickly. The system installs successfully. Power on and go to settings to check. Same serial number as before. And the iPhone now reports 2 terabytes of storage. The modification is complete. So, how much would you be willing to pay for such a unique 2 terabytes iPhone 17 Pro?